Students. So far we have discussed about solutions and suspension. Now comes the another mixture, that is colloids or colloidal solutions. So let me tell you students, a colloid is a kind of solution in which the size of solute particles is intermediate between those in true solution and those in suspensions. So it means the size of the solute particles in a colloid is much bigger than those in true solutions. Size of solute particles in colloid is bigger than that of true solution, but smaller than those of suspension. Though colloids appear to be homogeneous to us, particles are not visible to us, so it appears homogeneous, but actually they are found to be heterogeneous when observed through a high power microscope. So colloid is not a true solution. Okay, we are having lot of examples of colloids like soap solution, starch solution, milk, ink, blood, jelly, and solutions of synthetic detergents. These are all the examples of colloids. Colloids are also known as colloidal solutions. Now let's discuss the properties of colloids. The important characteristic properties of colloids are as follows. The first property is that a colloid appears to be homogeneous, but actually it is heterogeneous. Okay. So the particles of colloid are less than the particles of solution, greater than the particles of solution, and less than the particles of the suspension. So intermediate is the size of the particles. Okay, bigger than true solution, but smaller than those in suspension. It means the size of colloidal particles is between 1 nanometer and 100 nanometer, because the size is bigger than solution, true solution. So it means greater than 1 nanometer, and the size is less than suspension, so it means less than 100 nanometer. So in between 1 nanometer and 100 nanometer lies the size of the particles in a colloid. Another property of colloid is that the particles of most of the colloids cannot be seen even with a microscope, because they are not as big as suspension. Particles of suspension can be seen by microscope, in fact by naked eyes, but sometimes particles of the colloids cannot be seen even with the microscope because they are very small sometimes. And another property of colloids is that the colloids can pass through the filter paper. Particles of colloid can easily pass through filter paper. So it means a colloid cannot be separated by filtration, because if we pass a colloid through a filter paper, particles, as I told you, particles are small, less than the size of the suspension. So particles are enough small and they easily pass through the filter paper. So we cannot separate a colloid. We cannot separate colloids by filtration. Okay. Another important property of colloids is that the colloids are quite stable. Now, what do we mean by stable? So stable means that the particles of colloid do not separate out on keeping, because the particles are not big enough that they will get separated if we left our mixture undisturbed. No, particles are small, so particles are not particles do not get separated on keeping. Okay, on lefting it undisturbed, particles do not get separated. Another important property of colloid is that the colloids scatter a beam of light passing through it, because its particles are quite fairly large, so they can scatter a beam of light. So the path of the light becomes visible when it passes through colloids. No doubt, colloids, as I told you, that particles are fairly large, So that is why they are able to scatter beam of light. So path is visible. Path of light is visible when the light passes through a colloid. One more important thing is here, although colloids cannot be separated by the process of filtration, but a special technique known as centrifugation. Centrifugation technique can be used to separate the colloidal particles from a colloidal solution. So by filtration we cannot separate them, but we can separate them through centrifugation. Okay. Now, as I told you that the colloidal particles are big enough to scatter light. So what happens if a beam of light is put on a colloidal solution? As you can see here, I have taken three solutions. So three mixtures: solution, colloids, and suspension. Through solution, you cannot see the beam of light. Beam of light is not visible. But through suspensions and through colloids, a beam of light is visible because the particles are big enough to scatter light. So if a beam of light is put in a colloidal solution, say suppose soap solution, you have kept it in a beaker in a dark room, so part of light becomes visible. Beam of light is illuminated. It becomes visible when seen from the side. So the path of light beam becomes visible because the colloidal particles are big enough to scatter light falling on them in all direction. And this scattered light enters our eyes and we are able to see the path of the light beam. Okay. And students, let me tell you that the scattering of light by colloidal particles, it's known as Tyndall effect. The scattering of light by the colloidal particles, it's called Tyndall effect. And the scattering of light by the colloidal solution tells us that colloidal particles are much bigger than the particles of a true solution, because true solutions they are not able to do Tyndall effect. They are not able to show Tyndall effect because scattering is not happening there because the particles are small. So this scattering, this Tyndall effect tells us that yes, the colloidal particles are big enough than true solutions. So you can say that the true solution does not show Tyndall effect, but a colloidal solution shows the Tyndall effect. And Tyndall effects is nothing but the scattering of light. For example, when a ray of light enters a dark room, it's scattered by the dust particles present in the air, and then we are able to see that path of light clearly, right? Another examples are having of Tyndall effect, like you might have observed that when sunlight passes through the canopy of a dense forest, the path of light is visible there, right? So that is because of the scattering of the light, because of the Tyndall effect, that we are able to see the path of the light. Now, colloids do not involve only solids and liquids. They may also involve gases. So, colloids are classified according to the physical state of dispersed phase. Dispersed phase is nothing but solute. We have discussed this, right? So, colloids are classified according to the physical state of dispersed phase and the dispersion medium. Dispersed phase is nothing but solute and the dispersion medium is nothing but solvent. So most of the colloids can be classified into following 7 groups: sol, solid sol, aerosol, emulsion, foam, solid foam, and gel. And all these are actually the technical names of the group of colloids. So we'll describe all these colloids in brief. So first of all, let's talk about sol. Students, sol is a colloid in which tiny solid particles are dispersed in a liquid medium. So in sol, solid particles are dispersed in a liquid. So our dispersion medium is liquid and our dispersed phase is solid particles. And the examples of sol are ink, soap solution, starch solution, and most paints. Okay. Now another group of colloid is solid sol. Now we are having solid sol, where solid particles are dispersed in solid medium. Where solid particles are dispersed in solid medium, that is solid sol. Okay, and the examples are colored gemstones. In gemstones, we have actually solid particles dispersed in a solid medium, like ruby you are having. Okay, these are actually solid sols. Another group of colloid is aerosol. It's a colloid in which a solid or liquid is dispersed in a gas. Either solid is dispersed in a gas or liquid is dispersed in a gas. These are aerosols. And we are having, if I take a solid dispersed in a gas, then we are having smoke, we are having automobile exhausters. And if I am talking about the aerosol in which a liquid is dispersed in a gas, then we are having hairspray, fog, mist, in fact clouds. These are all aerosols. Okay. One more group of colloid is emulsion. Emulsion is a colloid in which minute droplets of liquid are dispersed in another liquid, and which is not miscible with it. Okay. So the examples of emulsions are milk, butter, face cream. These are all emulsions where a liquid is dispersed in liquid. One more group of colloid is foam. The foam is a colloid in which gas is dispersed in a liquid medium, like a fire extinguisher foam, where a carbon dioxide gas is dispersed in liquid. So bubbles, shaving cream, bear foam, these are all foams in which a gas is dispersed in a liquid. Then we are having solid foams, where a gas is dispersed in a solid, like foam rubber, sponge, or bread. There we are having gas which is dispersed in a solid medium. Okay. And the last group of colloids is gel. Gel is actually a semi-solid colloid in which there is a continuous network of solid particles dispersed in a liquid. As solid particles dispersed in a liquid is called sol, right? But here gel is the same, solid particles dispersed in a liquid, but it's actually semi-solid colloid, and we are having continuous network of solid particles, like you are having jellies, you are having hair gel. These are all these all belong to the group of gels. So this was all about the colloids.